Let's talk about radicals of higher indices. A square root has index 2, a cube root has index 3. What about something with index 4 or 5 or higher? What does that mean? Well, essentially the same concept as the square root or the cube root. Okay, the fourth root means we want to know what number we have to raise to the fourth power to make this radicand 81. Well, 81 is 3 times 3 times 3 times 3, 3 to the fourth power. So the fourth root of 81 must be 3. Okay? Similarly, with the fifth root of 32, we need to know what number we raise to the fifth power to get 32. That is 2. 2 to the fifth power is 32, so the fifth root of 32 equals 2. And in general, if we have the nth root of any number a is equal to b, that means the same thing as saying we need to raise b to the nth power to get a. Okay? Now, in this notation, nth root of a, once again, a is called the radicand, n is called the index, and the whole thing is called radical expression, or a radical. Let's see how to do this on the calculator. Again, return to the math menu. We saw the cube root here before. Right below it, it says x root. Well, that x means we can put in any index that we want to. So first, let's exit out of here. If we wanted to calculate, say, what we saw on the board a second ago, the fourth root of 81, what we would do is first put our index, then go to the math menu and select option 5. That will tell the calculator to find the fourth root. We then type in our radicand. It gives us 3. Exactly what we want it to. Let's see another example. We could do the fourth root of 14,641. Something that we can't necessarily see as easily as the fourth root of 81. Gives us 11, because 11 to the fourth power is 14,641. Of course, it won't always work out to a whole number. Let's say we take the fifth root of 100. It gives a decimal approximation around 2.5, because there is no whole number that's going to give me 100 when I raise it to the fifth power. 2 to the fifth power gives me 32, and 3 to the fifth power gives me 243. So I miss 100. It's about 2.5, but the calculator can only give me a decimal approximation. What if our radicand is negative? We saw for square roots that if the radicand is negative, we did not get a real number, because we can't square any number and get a negative number. Is that the same story for cube roots and other higher index roots? Well, let's ask ourselves, is there a number we can raise to to the third power, or multiply 3 copies of, to get a negative 64? Well, we know that the cube root of 64 is 4, because 4 times 4 times 4 gives us 64. Okay, well, what if we try a negative 4? We know that if we square a negative, it becomes positive, but what if we raise it to the third power? Well, negative 4 times negative 4 is a positive 16. We multiply positive 16 by a negative 4, we get a negative 64. So there's no problem here. The cube root of negative 64 is negative 4. Because if we raise negative 4 to the third power, we get negative 64. So with cube roots at least, it looks like we can take the cube root of a negative number and there's no problem. Okay. In fact, we saw with square roots that when we were able to take the square root, there were always 2 square roots, a principal or positive square root and a negative square root. But with cube roots, we just took the cube root without a positive or negative out front, and we got a negative number. As it turns out, there's only one cube root for any radicand, whether positive or negative. There's only one real cube root, not a principal root and a negative root. If we wanted to take the negative root, we can do that for sure. But really all we're doing is we're taking the cube root of a negative 64 and then we're taking the negative of that, which gives us 4. This is not a cube root of negative 64 because 4 cubed gives us 64, not negative 64. So this isn't the same idea as with square roots. This is not a valid cube root of negative 64. It's just the cube root of negative 64 and then we take the negative of it. What about the fourth root? Say we have the fourth root of negative 16. We need some number so that when we raise it to the fourth power we get negative 16. Well, if it's positive and we raise it to the fourth power, it'll still be positive, so it can't be a positive number. If it's negative and we raise it to the fourth power, well, then we've got negative times negative times negative times negative. Multiplying those two will make a positive. Multiplying those two will make a positive. Positive times a positive is positive. So again, we can't take a negative number to the fourth power and get a negative number. Just like with the square root, the fourth root of a negative number will not give us a real number. The idea we see here is this. Negative 2 squared is positive 4. Negative 2 to the third power is negative 8. Negative 2 to the fourth power is positive 16. Negative 2 to the fifth power is negative 32. And so on and so on. So as long as our exponent is odd, if our base is negative, then our answer is going to be negative. But if our exponent is even, we're going to get a positive answer regardless of whether our base is positive or negative. And this leads us to 3 possible cases. If n, the index, is even, and a, the radicand, is greater than or equal to 0, then this symbol, which we read nth root of a, represents the principal nth root of a. And this symbol represents the negative nth root of a, and that is how we read it, negative nth root of a. That's the first case. The second case is also if n, the index, is even, but this time if we have an even index and a negative radicand, then this symbol, the nth root of a, does not represent a real number. The third case is if n, the index, is odd. In that situation, it doesn't matter what a is, the radicand can be positive or negative. This symbol, the nth root of a, represents the only real nth root of a. Here's a quick example of those cases at work. The first one says the 6th root of 729. The index is 6, which is even. The radicand is 729, which is positive. Therefore, this falls under the first case. It should have a principal 6th root and a negative 6th root. The principal 6th root is 3. And this next one, this next symbol, represents the negative 6th root of 729, which will give us negative 3. If I take 3 and raise it to the 6th power, I get 729. If I take negative 3 and raise it to the 6th power, I get 729. This next one, 6th root of negative 729. Index is still 6, so it's still even, but now the radicand is negative. Well, anytime we have a negative radicand with an even index root, it's not a real number. What if we keep that negative radicand, but we change our index to 3? So now the index is odd. Well, that's the last case. Odd index, there's always going to be exactly 1 cube root, and it's going to be negative 9 in this case.